Hello children, in this video session we'll discuss these topics: primary colors, secondary colors, color addition, color subtraction. So let's get started. Primary colors. These are the basic colors that cannot be obtained from other colors. Okay, there are three primary colors: red, green, and blue. And in short form you can call RGB. And using these three primary colors we can get many colors. When we mix two primary colors in different proportions we get variety of colors. By mixing these three primary colors we can create a wide range of other colors, but these three primary colors cannot be created from any other colors. That's why they are called primary colors. In short form you can call RGB. All other colors are created out of combination of these primary colors, but the primary colors cannot be obtained from mixing any other colors. Is that okay? If you look at this slide, it will make you to understand. See how the different colors are created by mixing the primary colors in different proportion. When you mix the primary colors, three primary colors, red, green, and blue, in proper proportion, okay, you will get a white light. When you mix red, green, and blue in proper proportion, you will get a white light. Mixing primary colors of light in varying proportion can produce a wide range of other colors. Right? If you mix primary colors in different proportion, we get a wide variety of colors. Now let's come to secondary colors. What are secondary colors? Secondary colors are the colors obtained by mixing two primary colors. Okay, secondary colors are the colors obtained by mixing two primary colors. If you mix green and red, you will get yellow. If you mix green and blue, you will get cyan. And when you mix blue and red, you will get magenta. These three colors, yellow, cyan, and magenta, are referred as secondary colors. They are referred as secondary colors. And secondary colors are formed by the process of color addition. Okay, as I have said before, when you mix two primary colors, actually what we are doing, we are adding two primary colors. By doing so, we will get secondary colors, and that process is what do we say, color addition. When you mix two primary colors, we get a secondary color, and that process is what do we say, color addition. The process of creating various colors of light by mixing or adding three primary colors is known as color addition. What is color addition? It is a combination or mixing of two primary colors. That is what do we say, color addition. And it has many applications. Color addition has important applications in color television, color computer monitors, and on-stage lighting at the theaters. Each of these applications involves the mixing or addition of colors of light to produce a desired appearance. Right? On a color TV, on a screen of a color TV, we see different colors because of this process. Okay, color addition. How does a color TV work? Let's see. Television gives off light. To make color with a TV, you can use red, green, and blue RGB directly. This screen is made of tiny red, green, and blue dots. If you look at if you go to a TV mechanic shop where color TVs are repaired, you will find TV screen has tiny blue dots of red, green, and blue, and these dots are called pixels. Fine. TV sets mix these colors in different proportion to give different colors. Okay, TV set mixes these pixels in different amount to give different colors. That's why we can see color images on TV screen. Fine. These three colors are mixed in different proportion, and we get to see different colors. And you can say we are able to see color objects on color TV screen because of color addition. Fine. This is what we say, color addition, mixing of two primary colors in different proportion. And on stage lighting also, when we see different colors, when you see different colors, just think it is a work. It is done by color addition. It is done by color addition. Let's see this activity 4. To observe formation of secondary colors using primary colors. What you need? Take 3 touches and cover the glasses with red, green, and blue cellophane paper. Switch on the touches and project them on a white wall without any overlapping. There we will find 3 primary colors: red, green, and blue. we will observe three color circles on the wall: red, green, and blue. These are three primary colors of light, RGB. Right? This activity will be more successful if we carry out in a dark room. Now let two color circles overlap at a time. We will observe different colors in the area where the two primary colors overlap. And we will, when we do this combination, red and green, we will get yellow, blue and green, we will get cyan, and when we mix red and blue, we will get magenta. Right? This is how secondary colors are created by mixing two primary colors, or you can say by color addition. Okay, color subtraction. After discussing color addition, we'll discuss about color subtraction. Don't worry, there is only color addition and subtraction, no color multiplication and division. Don't worry about that. A color subtraction, we know that an object appears to be a certain color because it reflects that color, light, or a combination of colors and absorbs all the colors. Before understanding color subtraction, in the previous session, or you can see the YouTube video also, there we have discussed appearance of color of an object. The color of an object is the color which it reflects. Fine. Color of an object is the color which it reflects. This we have discussed. Okay, we can have a, let's look at this slide. Okay. Leaves appear green. Why does the leaves appear green? When a white light falls on a green leaf, what leaf does? It absorbs all the six colors and reflects the green light, and reflects only the green light. That's why green leaves appear green. This skin, this portion of the skin is blue. What is it doing? When the white light is falling on the skin, it is absorbing all the six colors and reflecting only blue. That's why we are able to see this part as blue color. Fine. The color of an object depends upon the two parameters: reflection and absorption. Reflection and absorption. Here the green light is getting reflected, so the color of this object is green, and all other colors are getting absorbed. Please keep this in mind. We will need leaves appear green because it absorbs all the six colors and reflects only the green color. That's why leaves appear green. Okay. Right now we have discussed color of an object is the color which it reflects. Fine. Color of an object is the color which it reflects. What happens when red rose is seen in red light? And this is important. What happens when red rose is seen in red light? It appears bright red because it reflects red light and absorbs no. Here no absorption is taking place. There no absorption is taking place. It appears bright red. Okay, when you see red rose, in red light, it appears bright red because it reflects red light and no absorption. And what happens when red rose is seen in green light? Okay, what happens when red rose is seen in green light? It appears black because it absorbs green and reflects none. When you see a red rose in green light, it absorbs green and reflects none. Fine. Do you know when does an object appears black? It appears black when it absorbs all the colors of light and reflects none. An object appears black because it absorbs all the colors of light and reflects none. And in the same way, an object appears white because it reflects all colors of light and absorbs none. Listen carefully, I'm going to repeat. An object appears black because it absorbs all the colors of light and reflects none. And if an object is appearing white, remember that it is reflecting all colors of light and no absorption takes place. Fine. If you want, you can make a note of it, a note of this. Okay. Let's see. If a light containing red, green, and blue falls on a red object, the object looks red because it reflects red and absorbs the green and blue light. Right now we have discussed color of an object is the color which it reflects. Okay, color of an object is the color which it reflects. Here three colors of light are falling on a red object. What the red object does? It absorbs green and blue and reflects only red. So the object will appear as red. Fine. Now if only green and blue falls on a red object, it will absorb both green and blue and it will appear black. Listen carefully. Here three colors of light are falling: red, green, and blue. What does this red object does? It absorbs both the colors, green and blue. It absorbs and reflects only red. So it appears as red. If only two colors of light falls, green and blue, then this will appear as black because it will absorb both the colors and reflects none. As you can see in this diagram also, three colors of light are falling. These two colors are getting absorbed and reflected one is Z. So the color of this object is Z. I have said before and I am repeating again, color of an object is the color which it reflects. Okay, let's see the examples of color subtraction. If magenta, which is the combination of red and blue, falls on the red object, it will reflect the red light but absorb blue light, as the object will appear to be red. When the magenta, which is a combination of red and blue, falls on a red object, the red object, as you can see in this slide also, blue and red magenta color, when it falls on a red object, it absorbs blue and reflects red. Fine. What happens if the magenta falls on a blue object? The blue object will absorb red and reflects blue. Okay. Next, if the magenta light red plus blue falls on the cyan green plus blue object, the object will absorb the red from the magenta and reflect the blue, hence the object will appear blue color. Here what happens? Blue, the magenta red and two colors red and blue is falling on the green and blue object. Right? This red will get absorbed and blue will be reflected. So the color of the object is the blue. Two colors of light are falling here. Red is getting absorbed and blue is reflected. So the color of object appears to be blue. If red falls on the yellow, green plus red object, the object will reflect the red light, hence the object will appear to be red. When a red falls on the yellow object, it will appear red bigger. Fine? Because that will reflect the red light. As you can see in this figure also, in this slide. If yellow, green plus red falls on a blue object, the object will absorb red and green and will reflect no colors, hence the object will appear black. And I have said before, an object appears black when it absorbs all the colors and reflects none. Here the same thing is happening. Here blue object is absorbing both red and green and is no reflection. So this object appears as black. If yellow, green plus red light falls on a blue object, the object will absorb red and green and will reflect no colors, and the object will appear black. Okay. Why does an object appear black? Because it absorbs all the colors and reflects none. Okay. And if somebody asks, why does an object appear white? Why does an object appear white? Now listen carefully. Why does an object appear? Suppose if I say here, why does an object appear white? What happens? What we can say here? It reflects all the colors of light and absorbs okay, and just two opposite cases are here. Right? Two opposite cases are here. Why does an object appear black? Because it absorbs all the colors and reflects none. Why does an object appear white? Why does an object appear white? Let me give you some other color. Let me give it white. I can give, as it will become not, as it will be invisible. Let me make this bold. Okay, let it be. Why does an object appear white? Because it reflects all the colors of light and absorbs none. Okay, this was the slide. When the two colors of light, red and green, is falling on a blue object, it is absorbing both the colors and it is reflecting none. So it is appearing black. Okay. Now this is the conclusion of what we have discussed so far. Is appearance of the color of an object is determined by identifying which color or colors of light are absorbed or subtracted from the original set of colored light. This process is known as color subtraction. mixture of colors minus color observed give the appearance of color. To understand this, let's discuss the slide which we have discussed before. Magenta combination of two colors, red and blue, is falling on the cyan object. Once it falls on the cyan object, red is getting absorbed, or you can say red is getting subtracted. If the red gets subtracted, which color remains? Blue. So the color will appear blue. This is what we mean by color subtraction, where a combination of colors is falling on the cyan object, and from this combination of color, red is getting subtracted, blue remains, and the color of the object appears blue. Okay, as you can see in this diagram. And this slide will help you to understand color subtraction more precisely. Right? Uses. Color subtraction is the basis for all color painting. Pigments of cyan, yellow and magenta are used to produce a myriad of colors, which means different types of color. These pigments are used to produce different types of colors. And color subtraction is the basis for all color painting. With this, we come to an end of this session. Thank you.